Hello everyone and welcome back to the channel. Now at this point in time, if you're watching when this video is made, you've already had your paper 2s for the May-June 2025 session for O levels, and what basically is now left is your MCQs and your ATP, which is your paper 4 paper. And to help you with this, I'm coming up with this playlist, and hopefully even someone who has not done a single ATP in his life before watching this video, at the end of this playlist he will be able to tackle most of the questions. So what is ATP all about? So first of all, know that ATP is just short for alternative to practical, and this is paper 4 of your O level paper. And basically what you talk about in this is you talk about how you would perform a practical if you were in the lab, right? So if you look at the past papers ever since the syllabus change in 2022, if you look at past papers either for O levels or for IGCSE, what you'll see is this, that the paper 3, which is practical, and paper 4, which is alternative to practical, are basically talking about the same experiment and they're identical in every regard, only that in paper 3 you'll be actually performing the practical. But for paper 4, you just talk about how you would do that if you had access to the lab. Now let's just talk about its layout a bit. So you have some questions from these, and this is not necessarily in the order. Most of the times the order remains the same, but other times it can be switched around, and maybe question number 1 would be something different, question number 2 would be something different. But most of the time what we've seen ever since the syllabus change in 2022, so we've had like 2022, 2023, 2024 as these papers, sorry, 2023, 24. So we have like a lot of papers there, and also this syllabus and how ATPs are tested, it's exactly the same for IGCSE and in O levels, only that the mark distribution is a bit different. So question number 1 is always related to, not always, but mostly related to scale measurements in some way. So you have to measure something, and again, most of the times it's some method 1 when you talk about how to determine a quantity, then you have a method 2, and then you compare and contrast, and at the end you have to comment on which of these methods was better, which one was more accurate. And this could be as much as many as for 3 methods as well. So instead of 2, maybe you could have 3 as well, but mostly it's between 2 or 3. Mostly it's 2, sometimes it's 3. So question number 1 is mostly on scale measurements. Question number 2 is usually an experiment that is related to some sort of calculation and analysis. So maybe you'll be given a formula and you just have to like use it and comment on what's happening, and then you can suggest improvements or why your result is not very accurate. So this is basically calculation and analysis, right? So this is also an important question, and again with this sometimes you have to suggest improvements, and that you can only get when you do repeatedly the same type of question related to a certain chapter. So let's say you're doing electricity questions and you do a lot of them, or maybe you do a lot of questions related to heat, then you actually start to get the drift of what this means, right? So question number 2 is mostly calculation and analysis. Question number 3 is related to drawing a graph, and the graph would either be a line of best fit or a curve of best fit, and then you need to extract something from it. Maybe you need to extract the gradient, and then you need to perform some calculations on it further to extract some quantity, or to extract the value of some constant. So this is what question number 3 is about. Question number 4, without fail, after the new syllabus, is called the planning question, where you basically talk about an experiment where you have to investigate the relationship between two variables and you say how that would happen. So that's question number 4, which is the planning question. So the order of these could be somewhat different. Sometimes scale measurements could be 2, calculation and analysis could be 1, or maybe like graphs could be 2 and calculation and analysis could be 3rd. But most of the time. This is the order that is followed, and always this is basically the layout of the questions, right? Sometimes one could bleed into another one. So maybe with scale measurements, you have something more related to calculation or analysis, or with graphs, you have some calculation and analysis, but otherwise, this is more or less how it goes. Now, apart from understanding, and we'll be doing this as well, that we'll be doing scale measurements questions, calculation and analysis, graphing, planning questions, all of these, it must also be noted that you need to have like a really good grip on your topics. Keep in mind, I'm talking about the topics, and by this I do not mean the theory of it. So for example, you'll never see a question like this in ATPs where you'll actually need to use a formula that you might have memorized and to do something like that. And it's very, very rare that you actually have to use some understanding, right? So you'll have to use something you already know. The only exception, I guess, would be something like that. For example, like circuit symbols you need to know, and some other things that are probably not occurring to me right now. Some of those things you need to know, but otherwise, this is a very easy paper. So the more questions you do of a certain topic, you already know what to write when, for example, commenting on analysis, why your results are not very accurate, and so on and so forth. What are some skills you need to know for this? And again, this is with respect to the questions that you have. So you need to know how to do scale measurements. And for example, if the examiner says that 1 centimeter on a diagram represents 5 centimeter in reality, then you know that any value that you measure using your scale, you would multiply by 5 to get the actual value, right? Apart from this, common length measurement instruments, experiments that you have. For example, if you want to measure the diameter of a ball and all you have is a meter rule, then you could do something like this, that you have this as a meter rule. You position the block in the middle and basically have it fixed between these two triangular blocks. And if you read this end and this end, so this gives you the diameter, right? This is one of these. We'll also come across other ones where you have to, for example, measure the length of a string. So that is something that's also important. Identifying sources of errors, or what is technically called uncertainties, and how you can improve on that. So for example, if you were expecting a certain value and if your calculated value is not exactly that, then how do you comment on what could be better? Method 1 versus method 2. So this is something we talked about. Usually question ones do compare these two methods, and using the experimental, looking at the experimental procedure you've used, you'll have to comment on which one is better. Point number 5, values equal within limits of experimental accuracy. So sometimes you'll have a question like this, that for example, you have one value of K that you calculated, let's say that is 9, and K2, let's say that is 10. And the question would say something like this, that they are equal within the limits of experimental accuracy if they are within 10% of each other. So how would you find whether both of these are in 10% of each other or not? So what you could do, for example, in this case, is you would find 10% of 9.9, which would turn out to be 0.9. So if you add 0.9 to this, so this is actually less than 10. So it's not reaching up to 10. So I would say that according to my results, these values are not equal. Drawing the lines and the curve of best fit. This is a more detailed discussion which we'll have when we actually do these type of questions. When you have to fill out the table of values, what things regarding significant figures and decimal places you have to keep in mind. A very important thing that a lot of people overlook is understanding that your experiment might not always be 100% accurate. So let's say, and there have been examples of this in the past, that for example, you do an experiment which is regarding reflection. Now in theory, you know that the angle of incidence is always equal to the angle of reflection. But if in an experiment, if they're not exactly equal, so maybe if instead of each of these being 48 and 48, maybe if one is 47, the other one is 49, this is fine. And a lot of the times the examiner, on purpose, he gives values like these to see that how many of the candidates would actually respect that it's a practical, and the values might not be 100% equal. Apart from this, when we talk about experiments where you have to comment on uncertainties and improvements, then it's important that you're not really quoting answers to older past papers and you're not saying general stuff. Like for example, if you just say avoid parallax error, then it's pretty obvious that nobody makes errors on purpose, right? And precision of reading. So if you are giving a reading, how many decimal places this needs to be equal to. So that's just like a really short introduction on what P4 is all about. Now, inshallah, we'll be going into the actual videos where you will see how questions 1 to 4 are tackled. And apart from that, we'll also be looking at how questions related to a certain topic, for example, like electricity or heat or other things like that are tackled. So keep watching and I'll see you in the next video.